2 weeks ago, I posted a video about building the NeoRAM expansion for the C64. If you haven't seen that video, check out the link in the description below. Since then, many people have asked me, what is the point of this RAM expansion if you can't play Sonic on the C64? And well, in this video we are going to explore the NeoRAM, which was originally called GeoRAM. Check out what's the difference to the classic REU or the RAM expansion unit for the C64 and what you can do with it. So let's get to it. Let's start with a little history lesson. The original REU, or RAM expansion unit, was shown on CES, Consumer Electronics Show, of 1985 by Commodore. It came in 3 models: the 1700 model, which had 128K, the 1764, which had 257K, and the 1750, which had 512K. Don't ask me what the name scheme is here, I have no clue. It consisted of DRAM ICs and some glue logic, and most notably, and other than this Neo or GeoRAM, it had something that's called a DMA controller. DMA standing for Direct Memory Access. The GeoRAM was released, this is not a GeoRAM, this is a NeoRAM. The GeoRAM was released in 1990 by Berkeley Softworks. That are the guys who made Geos for the C64. And they created this GeoRAM because Commodore stopped creating their own REUs, and Geos was barely usable without this RAM expansion. So they decided to do their own design and came up with a, let's say, cheaper solution and technically inferior solution because it didn't have this DMA controller, and that made all the difference. This GeoRAM came in 3 flavors, which were 512K, 1 meg, or 2 megs. And this one here just has 512K. You can add a second chip to have 1 megabyte, or all the 4 chips, then you would have 2 megabyte. And the very special thing that makes this NeoRAM, specifically this NeoRAM, interesting is that it has this 2032 battery in here. And that makes room for quite some interesting use cases we will get in a minute too. So to understand how a DMA controller works, which seems to be the dividing or deciding factor on these REUs, let's first check out how the GeoRAM or NeoRAM works. So if you have a C64 that has a CPU and it has 64K memory, and the CPU can access that memory directly. So you can say, give me whatever is in this place in memory, and it's delivered back, and the CPU can do stuff with that. CPU can also execute program code in this 64K of base memory. So if you add a Geo or NeoRAM, then you get something that is way bigger than that memory in here. So the NeoRAM is organized in banks, and every bank is 16 kilobytes. This NeoRAM has up to 2 megabytes of memory. The C64 has only 64 kilobytes of memory. So if we plug the NeoRAM, which is this huge thing here because it has much more memory than the C64, into the C64, then the C64 doesn't see this. It's completely ignorant of it because in itself the C64 can only address up to 64K through its 8-bit architecture. And to use this memory, the NeoRAM has so-called banks, which are 16K each. And what NeoRAM does is it provides a way, very simple program interface, to select which bank you want to use. So say this is bank 1, 2, 3, 4. And every bank is then again divided in blocks or pages, which are only 256 bytes. So what happens now is you tell it which bank to use, which block in this bank, because here are many of these blocks of 250 byte each. And the NeoRAM goes and puts this block inside the memory of the C64. So it shadows this specific space in memory. And this memory space or memory location is DE00 to DEFF, which is 256 bytes. So if you want to change that and use another bank, you just send the command and the memory block is shadowed over here. That means that you can, and that is very specific to the NeoRAM, and that is something the REU can't do, you can actually execute code inside of this 256 bytes right here, because the C64 thinks that is main memory, and C64 doesn't even know, or the CPU, that there's a NeoRAM connected. So that is the way the NeoRAM works. Since the NeoRAM has a battery, all the content that is copied into this memory, 65 bytes a time. So if you want to write 16K in bank 1, you would go and say select bank 1, block 1, write 256 bytes, then go and say select bank 1, block 2, and so forth until you have the bank filled. The CPU has to send this command to the NeoRAM, and then the NeoRAM shadows the little block in here in main memory. So problem or difference to the REU is the classic REU or RAM expansion unit can copy much more than just the 256 bytes. And it also can select at which place in memory it copies that stuff. The REU has memory banks which are 64 kilobytes, which would be the complete memory of the C64. And again, these are numbered and you can just tell it what to do with it. So the difference here is you can copy to any location in the C64 RAM. Let's say you want to use the REU as kind of a double buffer for your screen. Then you could just tell it to grab a portion of this bank and copy this small portion directly into the video RAM without the CPU even knowing, because the CPU does the following. Here is the DMA controller, and what the DMA controller does is it gets a command from the CPU, and there are 4 commands you can use. These commands are stash to put something in the REU, fetch to get something from the REU into the memory, swap to just switch, which you could use for double buffering, and verify to check if there's some specific data in the memory here. So you send one of these commands, you tell it which portion of the REU memory you want and how much of that memory, which is also a difference to the classic NeoRAM where you always have 256 bytes. You can freely select here as long as it's not more than 64K or a bank. And you tell it where to copy it to. So the interesting thing is that while the DMA controller does this itself, the CPU sends a command and CPU goes back to whatever it wants to do. But while the DMA controller works and copies stuff around, the CPU is halted. And only the CPU, all the other subsystems like timers and stuff, work just the way they do. You have to keep this in mind if you program for the REU, that only the CPU is halted, all the other systems are still running the same. And what Sonic uses or does is that it has, of course, CPU, the RAM, and the REU, And Mr. Sid, who made Sonic, told me that himself. He uses the REU to store lines of graphic, and then the CPU sends the DMA controller the information to copy one line of that into screen memory. So that portion of the C64, which if you put something in, like maybe you have done this in BASIC, you set a color via a poke or a character via poke. If you put this in here, then the line is displayed directly, and he doesn't copy the whole screen because the CPU is halted then, and all the interrupts which are needed to do various tasks wouldn't work anymore. So what he does is he does this line-wise, and by doing this line-wise, he copies a line, then the CPU goes back to work. He copies the next line, CPU goes back to work, copies the next line, and so forth. And that way he manages to get these super fast scrollings in Sonic. And that is why the REU works, but the NeoRAM doesn't work for Sonic, because it can do just this, copying stuff directly into screen memory. If you would try to do this with the NeoRAM, you would have to copy 256 bytes to that very specific location DE00, and then tell the CPU to manually copy from that location to, let's say here is screen RAM, to that screen RAM location. And that would take way too many cycles. And you could always only use 256 bytes, so you couldn't even tell it to copy the whole screen here and then do this line-wise, which would be a way, but that is too slow, and that is why Sonic will not run on Neo or GeoRAM. So the question remains, if Neo and GeoRAM cannot be used for Sonic or any kind of screen double buffering stuff, what is it good for? The answer is, it could be used as kind of a hard disk because it has a battery, and you can use GeoDrive, which pretty much announces this device as device number 2, like a floppy drive, and you can put stuff there with save whatever name, comma 2, comma 1, and load it with load whatever name, comma 2, comma 1. You can use this as kind of a very big C64 cartridge. The NeoSid player does just that, so you can load all the stuff once into the memory here. You can switch off the machine, you can put this away for, let's say, a year, so as long as the battery lasts. You put it in and you just type sys 57E3 and the program starts again because it is stored like on a cartridge. If you take out the battery, it's gone, but as long as the battery is in and it has some juice in it, this will store the program. I wrote a little basic program to illustrate how this bank switching and memory filling works. So you could do this in assembler, but I chose to do it in BASIC because I guess most of you out there are fluent in BASIC on the C64. And it's just a matter of peeking and poking stuff. So let's take a look at that little right now to show you my little program. And you can activate Neo or GeoRAM in Vice here. For that you go to Preferences, you go to Settings, you go to Peripheral, no, you go to Cartridges, and here you find the GeoRAM. You can even select up to 4 megabytes and make sure to enable the cartridge. And then you have that, and now it's present. And I wrote a little basic program, and I will just copy and paste that in here. Just say paste, and then it puts in the program, which is quite nice. Okay, so let's take a look at that. The first part is in line 10 that we select how many banks should be written, and the second line tells it how many blocks should be written. So you can have a maximum of 127 banks if you have 2 megabytes in this RAM expansion, and you can have a maximum of 63 blocks, which are these 256 byte blocks per read or write. So what we do is we iterate through all the banks, or from 0 to maxbank, and we tell the cartridge or the RAM expansion which bank we want to use. We do this by poke 57343. Then we go and do all the blocks for that bank. So we start with block 0 and we go to max blocks. In this case we do 3 banks and 3 blocks because we go from 0 to 2. And we print which bank and which block we are at right now, and we tell the GeoRAM or NeoRAM which block we want to use. For that we poke just the block at 57242, and then we go and poke the address, and the address is these 256 bytes, and it's from 56832 to 57087. It's always the same, so we're just poking the address we want to copy, and then we do. And what we do is we poke the number of the bank into that address. So we write content into the address which is selected here. And then we go and read. And this is the same way around. But this time we do a peek down here instead of a poke. So we still have to poke which bank to use and which block to use. But instead of putting something at this address, we are going to read the content of that address. And that address content should be the block that is currently selected. So we just print that on the screen. So let's run this. This is painfully slow in BASIC. In assembler, this would be just a second. And I just noticed that there's an error. Didn't copy the last line of my code. And there's the 0 bank, and there's the 1 bank. You see we actually filled the memory in the GeoRAM, and next should be 2. So the reason why we can always poke and peek from the same address is just this behavior that if we select a bank and a block, it is copied to this specific address in the C64's main memory. That is why we can always use the same address to write into different places of memory on the memory expansion or the GeoRAM. Yeah, so that is my little basic program. I will put it in the description and you can copy and paste it into Vice if you like. So let me give you a little demonstration on a real C64 what this NeoRAM can do for you if you're ready for it. So for me, one of the most interesting aspects of this NeoRAM, and I didn't tell that in the build video, is that it has a battery and that it can store stuff. So if we go and load the NeoTunes, that loads 512K of SID music onto that cartridge. And since there's a battery, it stores that, and I will load this now and I will fast forward this. And then I will switch off the machine, pull the cartridge, put it back in and show you that the content is still there. Okay, the banks are loaded and now the program is loading, and then we should be good to go. So here's NeoTunes, which just loaded, and yeah, let's switch the machine off and let's take out the cartridge, which is right here, so that you can see it's here. I had to switch this for this because that one had a fault and it didn't quite keep the storage, but this one is my good one, which I sorted in the video. So let me plug this back in. Let's switch the machine on again. Let me turn the camera and type sys57e3 and away we go. Just like a C64 cartridge, the stuff is in memory immediately. If you'd like to see more videos about what you can do with the NeoRAM, just let me know in the comments and I will do a video about it. So what do you think? Is this little device worth the $13 that it costs? I think it is. It's an interesting piece of hardware. You get a reset switch, which is quite nice, and you can use it as a hard disk and store stuff on it. So I think it's quite a cool device, and I really hope that there will be more software in the future. I will leave a link to more stuff in the description. And yeah, what do you think? Tell me in the comments, would you want one? Are you planning to build one? Do we know of any other software that makes use of it? So please share. And as always, thanks for watching and bye-bye.
Thank you for watching Retro is the New Black. If you are new to the channel, please like and subscribe. If you like the video, please share. Every like, share, and comment helps a lot. Until next time, bye-bye.